Hi everyone. So today in this session we will be taking up with the next topic, that is passive solar cooling. So till now we had dealt about the passive solar systems, okay? What are the various principles, what are the various design strategies, what are the various elements which are very much important in order to have a passive solar system, and we also got to know what are the benefits as well as ill effects that we are going to be seeing, or a drawback that we are going to see using a passive solar system. And also we came across the passive solar heating systems, where we got to know that how the heating up of a building is going to take place. Now again we got to know inside that there are so many various systems that happens in a building through various gains, and those were your direct gain, indirect gain as well as isolated gain, right? So after all this, now we are dealing with our passive solar cooling system, right? So how does a passive solar cooling happen in a building? Okay, so passive solar cooling system. Passive solar cooling or a passive solar cooling system. So now tell me, how does a cooling happen in a passive solar cooling system? So we are not going to use any mechanical devices or any electrical devices in order to cool up a system, okay? So it happens only based upon the reduction of the heat that is going to come to a particular building, okay? Or by making it to slow down the process of heating in a particular building. So this is how I am going to cool a particular building by using my passive solar energy, right? And by using a natural shades or a shelters and providing a various shadows or the shades, and by also by means of various objections or the obstacles that we are going to provide to a entry of a sunlight directly into a building at its peak hours. So by all these means we can reduce the intake of a heat energy or a solar radiation into a building, okay? Now by using, it is all by a research, so by using a shadings. So by using the shadings, it is seen that 90 to 95% of the sun's radiations that enter into the house can be reduced. So how does it help? So because of this, the amount of heat that is going inside or getting inside and getting trapped in order to warm up a building will be reduced. So what happens? The building is going to heat up slowly, right? So once when a building is going to heat up slowly, obviously it means that some amount of cool or a comfort in that particular zone is present when compared to that at the outer environment. The primary focus of these cooling system is, in order to cool a system, okay, is the entry of the sunlight is avoided to a maximum extent, okay? So that is, the heating up of a building is carried out slowly, and the other one is all the hot air or the solar radiations which are present, which are being trapped inside a building, should be removed or it should get out. So what are the two main primary focuses based on which our passive solar cooling works? One is making the system to heat up slowly, okay? So once the system is going to heat up slowly, obviously the cooling effect will be there. Second one, in order to remove the hot air which is present inside a building easily and faster, okay? Now the passive cooling system majorly depends on, or it relays on, the daily climatic condition or the daily temperature change and the humidity variation, okay? So based on these strategies, our cooling system is going to play a major role. Okay. Now let's see what are the various cooling strategies or the cooling techniques that can be utilized in a solar passive cooling system. Okay. Various passive solar cooling techniques. Okay. So the first one is, as I already told you, the shadings itself. Shading. Okay. So after shading, it is nothing but the ventilation. Okay. Which causes the free movement of air to take place. And once a fresh air enters into a building, obviously the system is going to remove the hot air which is already present inside and provide a comfort in a particular zone, right? And the third one is the solar chimney. Okay. Next. So what is the next technique? It is the thermal mass. So you might be wondering, thermal masses are utilized in order to have a passive cooling system in a particular building. What is it going to have here, or what is its work here? I'll explain you. So now, what is the fifth one? So fifth one is the wind towers. Okay. So what is the sixth technology? It is the evaporative cooling system. Okay. Yeah. Okay. So what is the next technology or the next technique that can be utilized? It is a courtyard effect. Courtyard effect. So the next technique which can be utilized in order to have a passive cooling in a particular building is passive down draught technique. Passive down draught technique. And the next method is lattice screens. Okay. Or they are even called as jali. Okay. And the last technique is the earth air tunnels. Okay. So these are the major techniques that are being utilized in order to cool a system passively. So where we are not going to utilize any mechanical devices or electrical devices in order to cool a system, right? So as I told you, the first one is a shading system that we are going to utilize. These shading systems are going to minimize the heat entry to a greater extent of 90 to 95%. And these shadings can be the artificial ones or the natural ones. And in these shadings, we have got two different categories. The first one is the external shading, and the other one is internal shading, or the exterior shading and the interior shadings. Now, how to cool up a system externally, or how to preserve the entry of a solar radiations into a system externally. So we have again got various tools or the various techniques that can be adopted in order to cool a system. The first one is providing the eaves. Okay. Okay. So providing the eaves. What is the function of these eaves? So these eaves are usually provided at the hangovers or the overhanging or the projections that are being provided from the rooftop itself. Okay. So it is nothing but the overhangings which are being provided or the projected from the roof will be having a slight bend at the junction or the slight bend at the corner, and those projections are nothing but your eaves. Okay. And what is the function of it? It to some extent it is going to avoid the entry of a light into a openings that are being provided in a building. Okay. At the same time, it will also help in directing the rainwater which is going to be falling over a particular building. So it has got various functions. So as per my cooling system, one of the function is this. Okay. So the next one is avings. Okay. Okay. So the next one is avings. What is the function of it? So the eaves, you can see the image that is getting popped out at the left side of me. So how it looks and how these radiations are being prevented from getting in through the eaves. Okay. So the avings, so what is the function of it? It is again going to provide a shade to a particular building by not letting most of the heat radiations into a building. So now these avings are the artificial shadings that we are going to provide at the outer side of the openings, which are movable and which are removable. Whenever I require or whenever the purpose is to cool a building or whenever the purpose is to avoid the entry of a sunlight, in those cases I can use these avings. So these are a rectangular shape or a rectangular form of projections, okay, which are made up of various materials, strong materials which will not be allowing the heat into a particular building. So you can see at the left side of me the image that is popping out and how a avings exactly looks like and how it is been installed. Now what next? So by using screens and shutters, you can again provide the cooling effect or the shadings in a particular building. So obviously you might have seen these screens provided at the outer end or the shutters at the outer end in order to prevent the entry of a hot air or the entry of a solar radiations into a building. So these are majorly utilized in most of the building. So like in your living areas, I mean to say at the balconies or at the verandas, in order to avoid the greater entry of a sunlight, you obviously put out those shutters that you placed which are made up of the wood, right, and the screens which are of a jali effect, which provide a jali effect, right. So those kind of screens or the shutters are going to serve the purpose of shading and provide a cooling effect in a particular building by making the system to get heated up slowly, right. Next, the other exterior shadings that we can utilize is the louvers. Okay, louvers. What are these? So you might have already come across these things, right. So majorly these lowers are utilized, or you might have seen whenever you go to a particular official buildings. Okay. Okay. So how do they look? And even in the ventilations in the various educational departments as well as the commercial areas, they use this. Even at your homes they use this lowers. How do they look? They are nothing but the planks or the bats of a wood or a particular material which are in a rectangular form, and they are slight bended, okay, which will be providing a privacy to a particular interiors, as well as a free circulation of air is taking place at that particular lowers. At the same time, what is happening? The entry of the sunlight is also going to be trapped or rejected. So these lowers can also be utilized in order to have a good shading effect in a particular building. So the next one is, this is all nothing but a natural cooling or the natural shades. How can you get a natural shade? Yes, yes. It is a hot summer and you are just walking through a particular place and you find a tree over there. Where do you go then? In order to comfort yourself and in order to gain a strength and in order to feel cool and comfortable. It is obviously the tree which is standing over there where you can get a shade or a shelter, right? So these are the trees and the shrubs. See, I am not using a word plant here, I am using a word shrub. Plant is different from a shrub. So keep it in mind, those are the trees and the shrubs. So as the shrubs are bushy in nature and have got a huge bulk of leaves which will be providing a shade to a particular building. So these trees as well as shrubs also serve the purpose of shading, which is going to avoid the entry of maximum amount of heat radiation into a building and provide a passive cooling in a building, right? So fine. How can you cool a system internally? Obviously through your screens, right? By providing interior screens or curtains, you can obviously reduce the heat entry directly into a building and then have a cooling effect. So what are those? By using screens and then the curtains internally, right? And usually you might have seen in most of the buildings the screens will be provided internally, which is also going to avoid the hot breeze that is going to enter into a building while the doors are open, right? Next, ventilation. What do you mean by ventilation? The word itself is telling you that it is a free movement of air. Ventilating. That is, I am making a vent which is making the free movement of air to happen, right? So ventilation, how does the cooling happen through the ventilation? By placing the vents at different elevations or in a different orientation from where the wind is going to blow, okay? Or depending upon the dimensions of the vents that I have provided in a particular building, this exchange of air is going to happen. So once the exchange of air is going to happen, obviously the hot air which was developed or present in a particular building will be kicked out. And you will be getting a fresh air entering into a building, which is going to provide a bit of cooling effect as well as a clear air to breathe by avoiding a suffocation in a particular building, right? So again in the ventilation, there are many ways through which the ventilation process can be enhanced and the effectivity of cooling can be happening, okay? Because each and every project has got different strategies and different criteria or the different systems that has to be adopted. So in case of ventilation, okay, so the first technique that we have is the stack ventilation. Stack ventilation. And the other technique that we have is the cross ventilation. Cross ventilation. Okay. And the third one we have is the night ventilation. Night ventilation. Okay. So we majorly have three different processes or the techniques through which a proper ventilation can takes place, where the first one is your stack ventilation, the other one is your cross ventilation, and the last one is your night ventilation. Now, how do these vents help in providing the ventilation, right? And how does the air exchange happen in these various ways? So, stack ventilation, what happens in case of stack ventilation is that based upon the thermal difference in a air or based upon the pressure variation or the difference in that of the air, okay, and where a thermal buoyancy is going to come into a picture is a major principle based on which your stack ventilation is going to run. So what happens here, the warmer air is lighter when compared to that of the cooler air. So what happens, the warmer air is going to rise up whereas the cooler air is going to draw down, right? So what happens, the ventilators are provided in such a way that in one of the facing the opening is present and at the other end of the wall the openings or the vents are provided at a top. Okay. So say for example at the south end I have openings which are a larger openings which will be during summer it will be taking a, so during winter it will be taking up a quite good amount of heat, but during summer I don't want that. So the shades are provided, but still the amount of hot breeze or the air which is going to enter will be obviously getting into it, or the system is going to heat up. Okay, so the system is going to heat up. So now I need to cool a system while it is a summer. So what to do? So obviously the hot air which is going to enter into a building should move out through some ways. So south facing walls have got a opening, and say for example in a north facing walls I have provided the openings at a top. The ventilators are being provided at a top. So what happens, the air which is getting into a building from this end will be obviously the air which is going to be lighter will rise up and then move in the upward direction, and a good fresh air has an opportunity or has a way to get into a building again, right? So the fresh air which is of a bit lighter or due to the living organisms present in a particular building, even the heat exchange takes place there. So the heating up of air takes place and that air is going to move out from the north vents which are being placed. Okay. So how, yeah, see. So this is the opening and this is the ventilators we have provided. So it's just a rough sketch in order to make you understand. So the air is coming or entering into a building in this way, and the hot air are going to move in a upward direction due to the thermal buoyancy. Okay. So this is how the hot air or the heat that is present in a particular building can be removed through your stack ventilation. So the image that is getting popped out at my left will provide you a clear image of what is happening in a stack ventilation and how from the opening the air is entering into a building and how the air which is getting heated up or warmed up is getting out from a building, right? Yeah. So now the next one is the cross ventilation. So how does this cross ventilation work? How is this cross ventilation going to work? Okay. So in this case what happens? The openings which are being provided in a building are faced in both the directions. So in one direction the opening is placed in order to get the air inside a building, and on the other end the air will be moving out or it will be rushed out. Okay. So what is happening here? See, this is the opening towards the south and this is the opening towards the north. So the fresh air is going to move into or the windward direction. So wherever the wind blow or the wind flow or the air flow is too high, at that side I have an opening, and on the other side I have an other opening which is just exactly the same. Okay. So what is happening? The air is getting into a building, and from the other side, so once the space is occupied by the air which is getting into it, the space which was already occupied by the air which is been heated will be pushed out or rushed out. We do know that the air does not have any mass, but it occupies this space. That is what is happening here. So what is happening? The air which is getting into a building from the one end will be having or will be occupying the space which is present interiorly, okay, and the air which was already present in the internal or in the building will be exiting out from the other window. Why is this happening? One thing is the air or the wind blow is having a pressure. So due to the flow movement or due to the movement of the air in an inward direction, that pressure is pushing the air which was present inside into the outer end. Okay, right. So the cross ventilation is going to happen in the when the windows are placed in the either direction. So from the one end the fresh air is entering, and from the other end the hot air is getting out, right. So from the image that is getting popped out here, you can see what is exactly happening in your cross ventilation and how the entry of a air takes place and it goes out. Okay, see, so this is how the air is getting in and this is how the air is getting out. So this is how the cross ventilation can be represented. So now, what is night ventilation? It is quite interesting, you know. Yes, what is this night ventilation? Yes. So the cooling up of a building or the exchanging of a cold air or a cold breeze is going to take place at the night time. So what is happening? Once when the hot air is present in a particular building, okay, during the night, the good and a cool air which is going to provide a comfort to a building will be let inside. That is, during the night time, the major cooling is happening in a particular building. It is also going to cool an entire system, at the same time provide a comfort of living inside a particular building by providing a cool or a lower temperature air into a particular building. Again, at the daytime, what is going to happen? As the entire system is cooled up properly and to a greater extent, the heat that is going to be coming into a particular building is obviously present, but the heating up of a system is going to take place slowly. So as I already told you, the main or the primary focus of a building, passive solar cooling buildings, is just to have a lowering down of a temperature that is getting into it, that is slow down the heating up of a building, and the other one is removing or rejecting the hot air that is present in a building. So here both the techniques are taking place. At the night time, the rejection of the hot air is taking place, and at the daytime, what is happening? Slow cooling is going to happen in a particular building. So this is how the night ventilation works, and you can see the image which is being popped out there, how the night ventilation takes place and how the wind movement happens, okay, or the air movement happens in a daytime and a night time, right. So this is how the ventilation works, or this is how the ventilation helps in providing a cooling effect in a passive buildings. Okay, next. So what is next? Yes, the third technique that we were having in order to have a passive solar cooling in a particular building was your solar chimney. What is the solar chimney? What is the solar chimney? You might have heard a word chimney, right? Why are these chimneys used and where have we used these chimneys? Yes. So, in most of the buildings where the kitchens, where the water heaters are present, the conventional water heaters which were present. So, all there what we are going to use? We are going to use a chimney. What is happening there? Yes, they are the structures, built structures that are going to eliminate the smoke or eliminate the unwanted dirt particles which are going to be generated when a particular system is getting heated, okay, and they are being provided at a higher elevation so that all these smokes which is being generated will be getting out, okay. At the same time, in order to provide a comfort in a kitchen while a cooking is carried out, we do have a chimneys, right, where the hot burnt oil is going to provide a greater suffocation. In order to remove the dirt materials as well as the oil materials that we are going to inhale, we use a chimneys. What is it doing? It is removing that dirt air or the warm air which is going to cause the suffocation for a person who is going to cook at that place. The chimneys are used. It is going to let out the unwanted air from a particular place, right. So, the solar chimney works majorly on the principle of your stack ventilation. What was the principle or how was your stack ventilation working? Yes, so yeah. So, it was based upon the temperature difference, right. It was based upon the temperature difference or the air pressure that is going to be developed, or even we can say that it is due to the thermal buoyancy which is going to take place. So, from the image that is been popped out, you can see here that the hot air is rising up, okay, and as the structure, as these solar chimneys are the massive structures which have got a wider dimension, as well as they are being placed at a higher elevation with a greater length, the hot air is being driven out, right. The hot air which is lifted up is being removed from the top of the chimneys, right. At the same time, the cold air is being drawn down, and then what is happening? The entire atmosphere of a particular building can be cooled, or it can be present in a comfortable manner. And you can see that at the top the roofings are also present. This is provided in order to avoid the entry of the rain, or in order to avoid the entry of any other organisms, living organisms, right. So, this is how your solar chimney is going to work, and the main principle or the strategy based on which it is going to work is the Stack's law or the stacking principle, or the how the stack ventilation is going to take place. In the same manner or in the same way, your solar chimney is going to work, right. So, the next one is your thermal mass. Yes, yes, it is a very good question. How does this thermal mass is going to cool up a system when these thermal masses are utilized in order to absorb the solar heat, store the solar heat and radiate the same whenever it is required when a temperature goes down in a building? Yes, it is quite interesting to have this thermal mass, and in most of the structures we do use the thermal masses in order to cool down a building, and in most of the heritageous buildings we do have this technique in order to cool up a building. Now let us see how the cooling is going to happen by using this thermal mass, okay. So, what is happening? What is happening? So, yeah. So, these thermal masses, if I am going to use a walls, okay, I am not making it a floor where a direct entry of heat is going to take place. So thermal mass, I can say that the thermal walls. So these walls are going to play a major role for the cooling up of a building. How are they going to cool up a building? So see, if a wall is present, obviously what is going to happen, you know the phenomena on which the thermal walls are going to work. So once when a heat is being directed over them, once when a heat is going to be falling over a thermal mass, the heat is being absorbed by your thermal mass, it is going to be stored and it is going to be directed in the interior walls through conduction. So if a process of conduction is slow and if the material which I am using for this thermal walls is not a good conductor of heat, and at the outer end if I have a wall which is going to have a greater radiating effect, then what is going to happen? Obviously the molecules which are being heated at the exterior are not going to come into a building in a smaller amount of time or in a slower duration or in a smaller duration. Obviously what is going to happen? When molecules are not able to move in a faster rate to the interiors, obviously the interior is not going to heat up fast. So the first main focus is been fulfilled, that is the interior or a system is been heated slowly, right? And the other one is, once if the radiating effect which is present at the outer end is greater, once when a temperature goes down at the outer environment, this will radiate the heat in a faster manner and then cool a system. And why do that cooling happen and why do that radiation happen? In order to reach the equilibrium with the external environment, right? So what is happening? Now did you get to know how this thermal mass can be utilized in order to cool up a building? Yes. So what is happening? The material selection is going to play a major role in the preparation or in the making up of a thermal wall in a cool manner or in order to have a cool system of a building. So what is happening? So if a particular thermal wall is having a greater radiation effect and a smaller conduction effect, so obviously the interior is going to get heated up slowly. Okay, so by the time the heat radiations or the heat reaches inside, the temperature would have been gone out, and obviously what would have happened? Obviously the radiations which are present in my outer end of the exterior wall will get out the heat and the system is going to cool up in a much more effective. So there is no provision of greater entry of a heat into a building, right? So this is how your thermal mass is going to help in order to cool up a system. So you can see the images which are being projected to my left, which are showing you how the heritageous buildings are utilizing the thermal mass in order to cool up a system, or a thermal wall in order to cool up a system by having the alternate cooling system. See, these things are like, it's a quite interesting thing where you have to use too many known technologies in one particular system and you get a best out of nothing, right? So this is how you can cool up a system by using your thermal mass or the thermal wall, right? Fine. So now the next technique is the wind towers. How the wind towers are going to help in a passive cooling up of a building, right? What do you mean by these wind towers? What are these wind towers? The word itself is telling you that the cooling is going to happen due to the movement of the wind, due to the blow of the wind. And where this wind is going to blow? In the towers. So in the towers, due to the movement of a air or the wind blow, the cooling up of a system is going to take place. And these systems, in order to have a greater absorption of the air or the greater or a high movement of the wind in a particular building, they are placed at very high elevation and at a very much greater length, where a good or a fresh air will be trapped inside, where it is going to move inside. Okay, once it is moving inside a wind tower, what is happening? So it is been drawn down. So what is happening? It is going to be moving in a downward direction. What is going to move in a downward direction? The wind which is present, which is been directed into a building, is going to move down, right? At the same time, what is happening? The hot air which is present in a building which has been raised up will be removed out from the same openings. Okay? And in order to have a good wind blow or the air capture, the openings are made at a larger end, or the openings are made to be in a greater extent. So greater dimension openings are being utilized in order to have a good air movement in a particular structure, that is your wind tower, right? So the image which is been popped out there, you can see how the wind movement is going to take place and how exactly the wind towers are being constructed and how the openings are being present in your wind towers, which is going to facilitate the capturing. So here the capturing of the wind is happening, not the capturing of the heat, right? So it is the wind which is being captured. Obviously that wind will be having some of the minute water vapors present in it. That is how the precipitation is going to take place, right? So you might have heard about the convection precipitation which is going to take place, right? So it is a hot summer and suddenly you are going to get a rainfall, right? So that is due to the change in the humidity. So you feel that it is highly humid and you suddenly see that there is a rain that is dropping over. So what is there? What is happening over there? That is because of the water molecules or the water vapors which were been present at the upper end, which were been lifted due to the warm air, and then that gets condensed and then the falling of a rain happens. So this is where your wind tower is also working. It is going to capture the movement of the air at the top and it is going to draw down that, or it is going to move down that air. Since the wind or the air is going to be blowing at a higher speed, that wind will be obviously entering into a space which is present, right? But at the same time, the hot air which is going to have a lower density will rise up and will be removed, right? So this is how your wind towers are going to help in cooling up of a system. Right. So now let's see what the evaporative cooling system means. What is evaporative cooling system? How does the cooling happen using your evaporative technique? Yes? Yes. So the evaporation itself is letting you know that it is the evaporated water molecules which will be going to provide a cooling effect in a particular building, right? So evaporation, how to provide this evaporation to happen? Okay, so how to enhance the cooling system through this evaporation? So in the design, you might remember we had even spoke about the roof ponds. Do you remember it? Providing a roof pond, whether I am going to provide a roof pond for the cooling up of a system or heating up of a system, right? I guess you do remember that. Okay, so in order to cool up a system, if I am going to use the ponds at a roof, okay, or if at all I am going to provide a sprinklers, okay, what is it going to do? Due to the movement of the hot air, okay, so this hot air is going to come in contact with this sprinkling water, and obviously what is going to happen? The heat which is present in your air will be absorbed by the water, and then the breeze becomes cool, or the air becomes cool. The movement of the air will be in a cool way or in a cool manner. So it is like the temperature of the air will get down due to the water molecules which are present there, and these water molecules, as they gain up the heat energy from the air, they are going to evaporate, right? Evaporate, and the air which has been striking or which has come in contact with the water would have cooled and gained a cooling effect, and that air is moving in a downward direction into a building, right? So the evaporative effect, that is the technique where the hot air, when it comes in contact with the water molecules are going to evaporate. At the same time, the air which is going to come in contact with the water will cool down and will gain a greater density and move in a downward direction. So based on this phenomena, our evaporative cooling system is going to work, right? And we have got various tools and various techniques in order to have a good evaporative cooling system. What are those? By utilizing a natural trees and shrubs, okay? By utilizing the sprinklers at the top, by utilizing the cellulose pad at the top, or by even having a roof pots at the top, by even having the conducts which are going to be carrying the water. So water circulation is happening in a particular building in a upward and downward direction. By even having the fountains in a particular building. See, fountains are not just provided in order to enhance the aesthetical appearance or the interiors of a building. Those are also provided in order to have a particular strategy or in order to get a particular useful thing to the interior, right? So this is how the evaporative cooling is going to happen in a particular system in order to achieve a passive cooling to happen in a particular building. So the image which has been popped out, you can see over there. So what are the various ways through which the evaporative technique can be utilized in a particular building, and how the coverings, that is the natural covering or a ground covering, is going to help in moistening or providing a good quality of air which is in a lower temperature or which is a very comfortable, which we exactly feel highly comfortable whenever the hot summer comes, okay? So, and also the sprinklers, how they are being provided at the top. And one more important thing is, this is going to the evaporative cooling is going to be more effective when a particular system, see, look at that, when a particular system is not going to have a flat surface, instead it is having a domed surface or any other shapes, okay? So the flat surface is going to be observing the more heat radiation when compared to that of the domed or any other shape structures. Why? Because once when a heat is falling in one direction, the other direction would have been cooling due to the shade that is going to be generated. The other region is not going to be receiving the heat. Okay, so the rising up of a sun and a falling up of a sun. So during the heating of the other end, the cooling would have happening, right? But if it is a flat end, what happens? All the time the heat radiation would be falling over a surface and the surface keeps on getting heated up. So the efficiency can be increased by utilizing the different shapes of a roofing instead of having a flat roof, right? Yeah.